The developer uses this technique to better organize their code so that essentially it's more reusable, meaning you write it once and you can use it on multiple occasions. And the idea is to encapsulate this code in a file and put it away, and then whenever you need to run the code, you bring in the file and you utilize the code that's already written. It could be written by you in the past, or it could be written by some other developer. But it's just a way of organizing the code so that it's reusable. All right, that's what object-oriented design's underlying purpose is to make reusability of code easier. Now, it does a lot of other things, and there's a lot of other principles that we're going to learn about, such as polymorphism and encapsulation and inheritance. Those are scary words, but trust me, you're gonna master those concepts after we go over the next couple of lectures. And since object-oriented programming is a way of organizing our code, there's a special keyword that's used often to bundle up certain things, certain objects, so to speak. Now, if you remember, we were using a list. So if you just type in list and you do a command or control click it, it'll take you to this code here, class list. Don't worry about the arguments here and don't worry about what this says, but notice it has some of the append, clear, copy. There's various methods here. Now, the actual code is not going to be visible in this editor because this editor hides away some of the scary details. But notice the basic structure. You've got a class keyword, and then you have the name of the class, and then you have all of these methods defined in it. So this is essentially a template of what a list ought to be like. And this code has already been written by the Python contributors so that we don't have to rewrite all of this ourselves when we would like to have the ability to utilize a collection of items. The list class takes care of that. So we're going to be creating our own classes, and you're going to learn all the ways in which you can utilize a class. So I'll start with defining a class here, and let's just call this class vehicle. And this class will be the template of what a vehicle is in our program. Okay? We define those details here. Based on the rules that we define in this class, the instructions that we write as part of this class, we are specifying in our program what a vehicle is. Now, if I try to run this code just like this, it's not going to run because it's an error. Notice it says end of file, because we need to have some code as part of this class. So if you'd like to get to the code later or have some other developer look at it later, you can add the pass keyword. And I showed you that you could do that with if-else statements and other nested blocks. And now this will compile. It still does nothing, but we do have a valid class called vehicle. So let's define the template of what a vehicle ought to be. The way to do that is you define a special method, okay? And you do it using the def keyword as we've been using. And then you give the name of the method a special name, and it's called init, all right? This is important. This init method is important because in this init method, you're going to specify how a vehicle ought to be created. This init is short for initialize. And so when you want to work with vehicles in your program, you're of course going to have many, many vehicles. So the definition of what a vehicle is and how it's supposed to be constructed or created or initialized, those instructions are going to be defined in this method, okay? Now it accepts an argument. By default, it takes self as the first argument. Don't worry about what this is just yet. We'll get into that later. Now the second argument to this could be, for example, the body type of a vehicle, right? Every vehicle has a kind of body, whether it's a sedan, a sports, a Jeep, what have you. So I'll just write body type here. That's the first argument, or the second argument in this situation that we expect the user to pass when they're trying to create a vehicle. And then to keep it simple, let's also get the make of the vehicle, all right? So we get the body type and the make. So the body type could be a truck, a bus, or a car, or whatever, and a sedan, and the make could be Honda or something, Honda or Toyota. Hopefully you get the idea. And then after pressing enter, going into this method, we specify the attributes of the vehicle here, okay? And so we're only really caring about vehicle's body and the vehicle's make, right? So we can say that vehicle body is equal to the body type that's passed in as the argument. And this is not complete yet. I'll show you exactly how to complete this. And then the next thing we have is the make. So we can say vehicle make and pass in the make that the user is going to be passing to us. And you're going to see this in action shortly. Now, I haven't really talked about the self argument just yet, and you're going to see exactly why it's needed, okay? So getting out of this method and out of this class now, after you come out of this code, we can move on to bigger and better things, right? So let's try to use this class. Let's say if I was to create a class, all I would do is car1, or name it anything. Let's just say I want to create a variable called car1, and I want to assign it a new vehicle. So I could use the vehicle class, and in the arguments, I can specify the body type and the make, just like we've defined up here. And so this is how a vehicle would be initialized. So the body type, let's say, is a Jeep, and the make is Toyota. So this is how you would attempt to initialize a vehicle, and we're saving that instance, that vehicle that we just created in the car1 variable. Now let's say that we wanted to print the vehicle's body or the make. I could do, let's try that, and you're going to see an issue that comes up. If we do car1 dot, notice we don't have access to any body or make. So if I do vehicle body, notice it doesn't know what this is, no suggestions. Hover your mouse here, unresolved attribute reference vehicle body or class. So I can't even print the data that I'm trying to save here. Let's run it. Notice it gives me an error. Vehicle object has no attribute vehicle body. So notice it says vehicle object. Now what is the object? The object is car1. Car1 does not have a vehicle body, does it? Well, you might say, wait a minute, but it's here. It's in this init method, and this method is used to initialize a new vehicle, right? So why isn't it being shown in car1? Well, the reason is we need to actually use self. So if we do self dot here, now all of a sudden vehicle body is exposed, okay? And you can check that. If you do car1 dot, you'll see that there's vehicle body as well as vehicle make. So let's print the vehicle body. Let's hit run, and the vehicle body is Jeep. And if we do vehicle make, you'll see that it's Toyota. Now that's car1. Let's create another car. I'm just going to copy this code and paste it down here again and change it to car2. Using the same template vehicle, I'm now going to create another kind of vehicle. So let's just say that this is a truck now, and the make of this truck is Mercedes. There you go, Mercedes. Now if I try to print the details of car2, I could do that right here. Print car2 dot vehicle make. Let's run this. And notice Toyota is the first car object. The second car object is Mercedes. So both of these are, the car1 and car2 are instances of a vehicle, okay? Where is the instructions defined of what a vehicle ought to be? They're right here in the vehicle class. So this self keyword was actually referring to the actual object. Now what is the object? This right here, car1, and car2 is the other object. That is why if we get rid of this self here, this vehicle body and vehicle make attributes are just floating in the air. They don't belong to any given object. That is why we need this self keyword here, very important. Now technically speaking, this car1 is just a variable and car2 is just a variable, but it's pointing to an object in memory, and we're going to get into those details later. Don't worry too much about what's going on behind the scenes, but understand that this is an object variable, and which means that it's an instance of a vehicle. And same thing with this car2. This is an object variable. It's a different object of the same type, vehicle. All right, so both car1 and car2 are a type of vehicle. As a matter of fact, let's print the type for car1. And I showed you the type function, right? So we could do car1 or car2 or whatever. Let's print the type for car1. Let's run that. Notice the type is vehicle right here. when you print that. Now, if you do car 2, notice the type is vehicle right here. And it also shows that it's coming from a class, of course. So just like this, I can have many, many different types of cars, different objects. I'll change this to car 2, car 3, car 4, car 5, car 6. We've got 6 car objects, 6 vehicle objects, but it's using the same template, and the values could be different. So here I can have sedan. For this one, I can have sport. Here it could be a motorcycle or another sedan down here. And let's say that this sedan is a Toyota and this sedan is a Honda, and the sport utility vehicle is a Mercedes, and the motorcycle is also a Mercedes, right? So 6 car objects, and we're initializing them. We're creating these objects here utilizing the vehicle class. Okay, and where are the instructions of what a vehicle is? That's in the vehicle class right here.